Good morning, students. So, yesterday we have completed the theoretical section of atoms. So, let me come across the problems. So, I go for almost all the NCERT problems and certain general problems. Before going to the problem section, we go for list of formulae. List of formulae or formulas. So, in the atom, the first atomic model is going to be proposed by whom? The Dalton. Then it is come across the J.J. Thomson. It is modified by Rutherford by using the large angle alpha scattering. Then again it is modified by Niels Bohr. So, when you come across the Rutherford's atomic model, he gave the size of the nucleus, that is nothing but 10 to the power of minus 15 meter, and size of the atom is 10 to the power of minus 10 meter. To determine the size of the nucleus, we come across the closest distance of approach, that is R0. Closest distance of approach R0 is equals to, that is 4k Z square divided by me square, where k is nothing but 1 divided by 4 pi epsilon naught. 4k Z square divided by me square. Now, this is going to be obtained when the alpha particle is approaching very close to the nucleus. There is a force of repulsion, there is a elastic collision. Hence, the whatever the kinetic energy which is used to approaching the nucleus, momentarily it stops, then again it retraces. When it stops, the kinetic energy is converted into electrostatic potential energy. By using that concept, we come across closest distance approach R0. Then impact parameter. Impact parameter is given by B equals to 1 divided by 4 pi epsilon naught Z square cot theta by 2 divided by kinetic energy half me square. Now, this is nothing but your impact parameter that measures the difference between the elastic collision and inelastic collision. Then after that, we come across Bohr's atomic model. In the Bohr's atomic model, the balancing condition, that is electrostatic force is balanced by centripetal force 1 divided by 4 pi epsilon naught Z into E divided by R square is equals to me square by R. Then Bohr's quantization rule. Bohr's quantization rule. Angular momentum mvr is equals to an integral vertical of h divided by 2 pi. Then Bohr's frequency condition. Bohr's frequency condition E equals to E2 minus E1. The electron jumps only to the permitted orbit when from higher orbit to lower orbit, then only it gives the energy h nu equals to E2 minus E1. Then nu equals to E2 minus E1 divided by h, where h is the Planck's constant. Now, these are the equations. Then after that, we come across the nth orbital energy, nth orbital radius, nth orbital energy, nth orbital velocity, then spectral series, then wave number, the total energy of the electron in the stationary orbit, all these factors. ये पूरे एक बार देख लो, पूरे equations. Already हम लोग theory में prove करे सो है. Right? एक बार देख लो. हो गया? Shall I go for next sixth equation? निकाल दो इसे? Yes. I go for sixth equation. Sixth equation is nth orbital radius. Rn is equals to नाही माझं पाय देश हिंट n स्क्वायर h स्क्वायर एप्सिलॉन नॉट mz स्क्वायर पाई नाही माझं पाय आपको मालूम है हिंट देश है. If you go for Bohr's radius for hydrogen atom, so that is first orbital radius is called Bohr's radius, that is 0.53 angstrom. If you go for nth orbital radius for Bohr's nth orbital radius 8, Rnth equals to point, that is n square into 0.53 angstrom for hydrogen atom. For first orbit n equals to 1, second orbit n equals to 2, third orbit we can calculate nth orbital radius for hydrogen atom. Then velocity, nth orbital velocity Vnth equals to z square 2n h epsilon naught, where n is the orbital number. That indicates that Vn is inversely proportional to n. As n increases, number of orbital state increases, the velocity of the electron in that respect to orbit decreases. Last orbital electrons possesses lesser velocity, z square divided by 2n h pi, right? Then we come across first orbital velocity v1 equals to c divided by 137, where c is the speed of light, right? Then we come across 11th, dekh lo ek baar, 11th one, that is nothing but nth orbital velocity c by n into alpha, where alpha equals to c by n 0.0073, where alpha equals to 0.0073, that gives a certain constant values. For first orbital velocity c by 1 into 0.00, second orbital velocity c by 2 0.0073, third orbital velocity c by 3 0.0073, right? Then shall I go for nth orbital energy? Right. Then after this we come across the total energy of the electron in the stationary orbit, the kinetic energy and potential energy. The kinetic energy is nothing but half m e square. This half m e square is obtained. We get the equation balancing condition, m e square by r is equals to 1 divided by 4 pi epsilon naught z into e divided by r square. M e square is equals to 1 divided by 4 pi epsilon naught z square by r. So when I substitute here, kinetic energy equals to 1 by 2, 1 by 4 pi epsilon naught z square by r. Then potential energy, the electrostatic potential energy, that is potential energy due to system of two charges, 1 divided by 4 pi epsilon naught z into minus e divided by distance, that is nothing but minus 1 divided by 4 pi epsilon naught z square by r, right? When I take this concept, therefore kinetic energy equals to 1 by 2 as it is. This complete term is nothing but minus of potential energy. Kinetic energy equals to half of the minus of half potential energy. Potential energy equals to minus of 2 times kinetic energy. Potential energy equals to minus of 2 times kinetic energy. पूरे उधर है देखो. Then what about the total energy? If I go for total energy, E equals to potential kinetic energy, so 1 by 2, 1 divided by 4 pi epsilon naught z square by r. Potential energy, that is nothing but minus 1 divided by 4 pi epsilon naught z square by r. So when I take the common, 1 divided by 4 pi epsilon naught z square by r, half minus 1. That is nothing but minus half 1 divided by 4 pi epsilon naught z square by r. So half 1 divided by z square by r. This complete term is nothing but E equals to minus kinetic energy. Kinetic energy equals to minus E. Total energy equals to माइनस काइनेटिक एनर्जी. पूरा सॉल्व करके बताए सो देखो पूरा टर्म्स. एक इक्वेशन याद रखना है सिंपल. देन पोटेंशियल एनर्जी ए इक्वेशन याद रखना है. देन काइनेटिक एनर्जी पोटेंशियल एनर्जी इक्वल्स टू माइनस 2 टाइम्स काइनेटिक एनर्जी. देन टोटल एनर्जी इक्वल्स टू माइनस ऑफ काइनेटिक एनर्जी. राइट. After substituting the value of r, nth orbital energy from this equation, देख लो एक बार. ये concept important है. This concept and this concept is important. दोनों को याद रख लो. आपके नीट के लिए, सीईटी के लिए, जेडब्ल्यू मेंस के लिए खाली इतना बस है. पूरा इक्वेशन आप कर सकते हैं. थ्योरी में पढ़े बोले तो आराम से कर सकते हैं आप. Shall I go for nth orbital energy? Yes. एक बार पूरा ग्लांस कर लो इक्वेशंस. आपके सामने रखे सो पूरा. राइट. निकाल दूं? यस. काइनेटिक एनर्जी इक्वल्स टू माइनस ऑफ टोटल एनर्जी और टोटल एनर्जी इक्वल्स टू माइनस ऑफ काइनेटिक एनर्जी. देन पोटेंशियल एनर्जी इक्वल्स टू माइनस ऑफ 2 टाइम्स काइनेटिक एनर्जी. राइट. देन देख लो nth ऑर्बिटल एनर्जी. nth ऑर्बिटल एनर्जी हिंट दिए सो आप लोगों को. nth ऑर्बिटल एनर्जी माझी आत नाही n स्क्वायर s स्क्वायर एप्सिलॉन नॉट स्क्वायर. झूठ बोल रहे माइनस. For hydrogen atom, by considering z equals to 1, nth orbital energy minus 13.6 divided by n square electron volt. 1 electron volt equals to 1.6 into 10 to the power minus 19 joules. आप पढ़े सो है. Right? By using this equation, we calculate the energy of the respective orbit, first orbit, second orbit, third orbit. At infinite, n equals to infinity, E equals to infinity gives 0. That is called ionization energy. For hydrogen atom, for ground state, total energy is minus 13.6, ionization energy is plus 13.6. So, yeah. Then, if you consider in general, for any atom in general, nth orbital energy minus 13.6 divided by n square z square in terms of electron volt. Hydrogen रहे तो z equals to 1, this equation. Right? Then after this, we come across wave number. निकालो इसे. Then I come across wave number. That gives the reciprocal of wavelength. How much number of waves are containing in 1 meter length of the medium that measures wave number. So nu bar equals to 1 by lambda r 1 by n1 square minus 1 by n2 square. If n1 equals to 1, we get Lyman series. If n1 equals to 2, Bohr series. n1 equals to 3, Paschen series. n1 equals to 4, bracket series. n1 equals to 5, Fund series. So we can calculate the respective wavelengths. Right? Then what is that? R, Rydberg constant. R equals to 8 epsilon naught square CH cube. Its value is 1.097 into 10 to the power of 7 per meter. Right? This is about our Rydberg constant. Right? Then we can calculate the series limit. That is nothing but n2 equals to infinity, minimum wavelength. Then maximum wavelength. देख लो इक्वेशन पूरा थ्योरी में करे सो है और एक बार रिवाइज कर रहा हूँ मैं. I go for minimum wavelength. Lambda minimum is equals to n1 square by r, because lambda equals to lambda minimum when n2 equals to infinity. This is also called series limit. Then for maximum wavelength, lambda maximum 1 by lambda maximum is equals to r 1 by n1 square, but n2 equals to n1 plus 1 whole square, because lambda equals to lambda maximum when n2 equals to n1 plus 1. Right? So these are the equations to calculate the maximum wavelength and minimum wavelength. एक बार पूरा इक्वेशन को रिवाइज कर लो. हो गए पूरे इक्वेशंस? यस. Then I go for NCERT problems. Right? पूरे प्रॉब्लम सिंपल है, उसके बाद जनरल प्रॉब्लम्स करेंगे. Shall I go for the NCERT problems? पूरे हो गए? Yes. I go for NCERT problems. प्रॉब्लम के लिए इससे पहले भी मैं प्रीवियस क्लासेस में बोल दिया मैंने. सो डोंट टेक द टेंशन. जितना आपका थियरी परफेक्ट रहेगा उसी तरह से आपका प्रॉब्लम सेक्शन भी परफेक्ट होगा. बहुत सारे बच्चे प्रॉब्लम बोले तो डर जाते हैं. कोई डरने की जरूरत नहीं है. NCERT प्रॉब्लम्स. देखो फर्स्ट प्रॉब्लम. What is the shortest wavelength? What is the shortest wavelength? Shortest wavelength. What is the shortest wavelength present in Paschen series? In Paschen series of spectral lines. Of spectral lines. This is my problem. Simple problem. Shortest wavelength, that is nothing but minimum wavelength. कौन सा सीरीज है? देखो Paschen series. आपको हिंट दिया सो है LBP, BP, Lyman, Balmer, Paschen, bracket, fund series, N1, 1, N1, 2, N1, 3, N1, 4, N1, 5. If the electron jumps from any higher orbit to the first orbit, we get Lyman series, second orbit, Balmer series, third orbit, Paschen series, N1 equals to 3. Confirm हो गया. Then, solution. For Paschen series, N1 equals to 3. We know that lambda is equals to lambda minimum when N2 equals to infinity. Therefore, 1 by lambda equals to r, 1 by n1 square minus 1 by n2 square. Therefore, 1 by lambda minimum is equals to r, 1 by n1 square minus 1 by infinity square. So this is nothing but r by n1 square. Lambda minimum equals to n1 square by r. n1 equals to 3 square, r equals to 1.097 into 10 to the power of 7. So lambda minimum is equals to 9 divided by 1.097 into 10 to the power of minus 7 meter. Right? So अब डिवाइड करो, कैलकुलेटर है, आर तो मालूम है, दैट इज अ स्टैंडर्ड वैल्यू. राइट? वी गेट, डिवाइड करें तो 8.2265 इंटू 10 टू द पावर ऑफ माइनस 7. अगर इतना लिखना चाहे दो जगह हटा दो, 822.65 इंटू 10 टू द पावर ऑफ माइनस 9, 822.65 नैनोमीटर. दिस इज योर आंसर. एक बार पूरे इक्वेशन को देख लो. The wavelength of the spectral series presents in 8.2265 nanometer. 8.22, that is 822.65. दो जगह हटा दे, that is 822.65 नैनोमीटर. सही है? इधर लिखे सो है. देख लो, सिंपल प्रॉब्लम. डायरेक्टली लिख सकते हैं यहाँ पे, थोड़ा स्टेप्स बढ़ने के लिए करे सो है. समझ में आया तो नेक्स्ट जा सकते हैं. पूरे प्रॉब्लम्स ईजी है. Shall I go for the next? निकाल दो? Yes. Let me go for second problem. What the second problem tells? देख लो क्या बोल रहा हूँ. So second problem. A difference of a difference of 2.3 electron volt separates two energy levels in an atom. Full stop. What is the frequency of radiation? What is the frequency of radiation when the atom makes a transition from the upper level to the lower level, from the upper level to the lower level. When the electron jumps from higher orbit to lower orbit, it emits energy. So the energy difference between the two states is given. देखो इधर ये है, the energy difference between the two states E equals to 2.3 electron volt, 2.3 into 1 electron volt, that is 2.3 into 1.6 into 10 to the power of minus 19 joules. So what is the frequency condition? what is nu? Right? We know that when the electron jumps from higher orbit to lower orbit, energy emitted E equals to h nu. So nu equals to E by h. E equals to 2.3 into 1.6 into 10 to the power of minus 19. So Planck's constant 6.625 into 10 to the power of minus 34. Easily calculation कर सकते. So when you do the calculation, we get nu equals to 5.6 into 10 to the power of 14 hertz. Check कर लो. Right? 5.6 into 10 to the power of 14 hertz. Simple problem. The energy difference between the two states this way. When the electron jumps from higher orbit to the lower orbit, it gives energy E. Then what is the frequency condition? E equals to h nu. Nu equals to E by h. Say yes. Shall I go for third problem? Next, third problem. Third problem, देखो. So what is going to be tell in the third problem? The ground state energy of hydrogen atom is minus 13.6 electron volt. Full stop. What are kinetic and potential energies of the electron in this state? Already आपको हिंट दे सो है. The first orbital energy, that is nothing but ground state energy, is given. Ground state energy E equals to minus 13.6 electron volt. Right? Then what are the potential and kinetic energy? अभी करो सो है. We know that total energy E equals to minus kinetic energy. Right? Potential energy is equals to minus 2 times the kinetic energy. अभी करे सो है. Then which implies kinetic energy equals to minus E. E is equals to minus, what is E? Minus 13.6 electron volt. E is equals to plus 13.6 electron volt. This is your answer first. Then potential energy equals to minus 2. What is the kinetic energy? Plus 13.6 electron volt. Plus into minus, minus 12, 6, 7, 2, 27.2 electron volt. This is your potential energy. देख लो एक बार. अभी पढ़े सो है. लिस्ट ऑफ फॉर्मूले दे सो है. वहाँ पे देखो. आई नीड काइनेटिक एनर्जी, माइनस इधर शिफ्ट करो. माइनस ऑफ माइनस प्लस 13.6. काइनेटिक एनर्जी पॉजिटिव रहता है. ये रहना जरूरी है. पोटेंशियल एनर्जी नेगेटिव. दैट इंडिकेट्स दैट बॉन्डिंग बिटवीन द न्यूक्लियस एंड इलेक्ट्रॉन. नेगेटिव साइन क्यों है बोले तो टोटल एनर्जी भी नेगेटिव आ जाता है बिकॉज द एनर्जी possessed by the electron in the respective orbit, because of the beingness of the electron in the orbit, it possesses potential energy and kinetic energy, then it gives the total energy. There must be the negative sign. That indicates again, once again, total energy bondish. Right? देख लो एक बार, सिंपल है और कुछ नहीं. So shall I go for one more problem? Fourth problem. देख लो. सही है? These are the two important factors. Then I go for fourth problem. NCERT के. Fourth problem क्या बोलता देखो. Every problem is the simplest one, but only thing is how you are going to be approach it. Right? The fourth problem, a hydrogen atom initially in the ground level, absorbs a photon, which excites it to the n equals to 4 level. That is fourth orbit. Determine the wavelength and frequency of the photon. Determine the wavelength and frequency of photon. Right? When the electron absorbs the energy, it is get excited. It moves from lower orbit to higher orbit. When the electron jumps from higher orbit to lower orbit, it radiates the energy. It is absorbing. It moving from lower orbit to the higher orbit. What is the lower orbit? Ground state. That is first orbital state. Then it goes to the fourth orbital state. Hence, energy absorbed. Solution. Energy absorbed. बोल सकते हैं. E equals to difference in the energy level, higher energy state E4 minus lower energy state E1. That is nothing but it goes for lower energy state to the higher energy state. Right? So हम लिख E2 minus E1 लिख सकते हैं ना. So higher energy state, lower energy state. Then we know that let nth orbital state minus 13.6 divided by n square electron volt. बाद में change करेंगे. So E equals to minus 13.6 divided by 2 square minus of minus 13.6 divided by 1 square in electron volt. So E equals to 13.6, right, divided by 1. This is plus minus 13.6 divided by 4. It is in terms of what? Electron volt. So shall I take 13.6 outside? 13.6 बाहर ले 1 minus 1 by 4 is in terms of electron volt. So higher orbital state is 4n equals to 4, right? 4. This is 16. Correct. higher energy state is nothing but n equals to 4. This is an important factor. Ground state n equals to 1. लिख सकता हूँ मैं, right? Then E4 minus E1 डाले तो भी चलता था. Shall I write it? E equals to 13.6 into 16 minus 1, 15 by 16 electron volt. That is 1 electron volt. So E equals to 13.6 into 15 divided by 16, 1 electron volt. 1.6 into 10 to the power of minus 19 joules. Right? If you go for the calculation, then we get 20.4 into 10 to the power of minus 19. यहाँ पे कैंसिल कर सकते हैं. E equals to 20.4 into 10 to the power of minus 19 joules. We do the necessary cancellation and go for cancelling the terms. कैलकुलेटर यूज कर सकते हैं. सीईटी में उसका मेथड कैसा है बोल देंगे. राइट? यहाँ पे E2 बोले तो n equals to 2 मत डालो. दैट इज E4 माइनस E1 भी लिख सकते हैं. इट्स सिंपली E4 minus E1. Higher energy state is E4, lower energy state is E1. 4 square, 1 square. किरकिरी नको. Right? Then after getting this energy, we can easily calculate the frequency and wavelength. देख लो एक बार. Right? E equals to h nu, nu equals to E by h. Then C equals to nu lambda. Lambda equals to C equals to nu lambda. Lambda equals to C by nu कर सकते हैं. अब एनर्जी कैलकुलेट करेंगे. सही है? एक बार पूरा देख लो. Then I go for frequency and wavelength. For frequency, shall I go for frequency vector? Right. सही है ये. And I go for frequency. For frequency. Frequency होना है. For frequency. E equals to h nu. Nu equals to E by h. What is E? 20.4 into 10 to the power of minus 19. 6, h equals to 6.625 into 10 to the power of minus 34. By doing the necessary cancellation, we get, so nu equals to 3.076 into 10 to the power of 15 hertz. अब ग्रेटर देन 5 है, एड 1 टू द प्रीवियस. इसको ऐसा भी लिख सकते हैं. कैलकुलेटर है, आराम से डिवाइड कर सकते हैं. राइट? दिस इज आवर फ्रीक्वेंसी. फॉर वेवलेंथ, for wavelength. Let C equals to nu lambda, lambda equals to C by nu. C 3 into 10 to the power of 8. What is nu? 3.1 into 10 to the power of 15. 3 cancel करे 1 हो जाता. So denominator is greater, that is less than 1, 0.9 something. So right, so shall I write 9.74 into 10 to the power of 8. ऊपर गया तो -8 मीटर. 0.974 into 10 to the power of 8 minus 15, 7 हो जाता. 0.974 into 10 to the power of 8 minus 15 minus 7, एक जगह हटा दो. 9.74 into 10 to the power of -8 ये है. राइट, इसको आप ऐसा भी लिख सकते हैं 0.974 into 10 to the power of -7 मीटर. ये जगह इधर ले लो, यहाँ पे रेस करो. 9.74 into 10 to the power of -8 मीटर. right? These are the 4 problems we have done in the first problem session. The remaining problems we go for what? Next class. पूरे easy problems से आराम से कर सकते हैं. मैं list of formula कर लिए, जितना हो सके उतना easy कर लिए, then we solve the NCERT problems. I hope that you have understood. कुछ भी दिक्कत रहे तो एक बार पूछ सकते हैं आप लोग comments में. Is it clear? Yes. So let me continue in the next class. That is nothing but remaining problems. Thank you.